So in this clip, we're going to show that the trace of a sum of operators is the sum of the traces of the operators, and that's probably no big surprise, but it's actually a little tricky to prove in general. So observe that if we have, by in general, I mean for operators as opposed to matrices. So for matrices, it's super simple, right? If we have two matrices of the same size, then the trace of A plus B is going to be the trace of A plus the trace of B just by looking at the diagonal entries. So in other words, it just boils down to the idea that the sum of AJJ plus BJJ, which is the thing that you use to compute the trace of the sum, that's equal to the sum of the A diagonals and the sum of the B diagonals, which are the things that you use to compute these two, right? So there's no big whoop going on there. But if we want to translate this to operators, it's not quite so easy because there is in general no relation between, or no way to get the eigenvalues from a sum in terms of the components. So the eigenvalues of S plus T in terms of the eigenvalues of S and the eigenvalues of T. So that actually makes this proposition somewhat non-trivial. So suppose that S and T are operators on a finite dimensional vector space. Again, the finite dimensional part is implied because we're going to be talking about matrices. Then the trace of S plus T is equal to trace S plus trace T. Okay, so for the proof, it's a straightforward computation with the tools that we've collected. So the trace of S plus T is equal to, and we just convert everything into matrices where life is simple, and then come back. So the trace of the matrix S plus T and so that's by 10.16, and then this is going to be the trace of MS plus MT, and this is by 3.36, which is a theorem that we have relating the matrix of the sum to the sum of the matrices. And then this is going to be equal to, and now we can split apart the trace MS plus trace MT, and this is by the observation from at the beginning of this clip. And now we put it back in terms of operators. And that's using 10.16 again.